All right, guys, this is the video for 7B, and this is just like 7A. Obviously, you're just getting extra practice. So I'm going to do about half of this with you, and the other half is homework. So number one is actually going to be homework. So number one, I'm going to mark as homework. Are you going to go back to do that after you watch the examples that I do for you? Okay, so I'm going to do number two for you. Okay, and number two, they want us to create an equation for a cubic function. Okay, so we know this is x cubed is going to be the highest exponent. It's a third degree. And they want us to write our answer in standard form. They give us the x-intercepts. Okay, remember this is just another example, or another word for zeros or real roots. And since they give them to us, I'm going to go ahead and plot those right now on the graph. This is -3. We have +1 and +7. All right, so we have these. And we also have to have it pass through this point, -2, and this is an xy coordinate, -2, 54. So -2, 54 would be right about here. Okay, so basically we've learned in 7A that the zeros can give us the factors. Okay, so from the 0 of -3, we know we have a factor of x plus 3. And from the 0 of a +1, we have a factor of x minus 1. And from the 0 of x plus 7, we have a factor of x minus 7. But we don't know this lead coefficient, which we call a. All right, so we need to find the specific a value. Okay, so this is our job throughout this whole lesson, is to find the a value that makes this polynomial graph go through this specific point. All right, so in this lab, we need to solve for a. And in order to solve for a, that means a can be our only variable. So I have this factored form, this general factored form with a missing. And I know this point, -2, 54, has to work in this equation. So what I'm going to do is I'm going to substitute 54 in for y. Okay, we're solving for a. And I'm going to substitute a -2 in for x for all three of my x's. Okay, so when the input x is -2, the output should be 54. Okay, so, and this looks easier, or it's easier than it looks. -2 plus 3 is just 1. Okay, -2 minus 1 is -3. And -2 minus 7 is -9. So really, 54 is equal to -3 times -9 times 1 times a, which is simply just 27a. So when I divide by 27 to solve for a, I get 2. So my a value is 2. All right, so I can write my factored form, which is my a value is 2, and then I can write my factors with the x value. Okay, I just substituted a certain xy value temporarily with just one single point on the list of infinite points on the graph to solve for the a value. So this is what's called factored form. Okay, so this is factored form, but they want standard form. They specifically asked for standard form for my answer. So in order to get standard form, I have to multiply the factors together. And I think I mentioned in 7A that I like to work from the back. So if first I'm going to multiply these two binomials together, and when I multiply x minus 1 times x minus 7, I get x squared minus 8x plus 7. And I also need to multiply that product times the 2 times x plus 3, so I'm going to multiply this I'm going to distribute to get 2x plus 6. And then my final answer would be this binomial times this trinomial. So I have to distribute the 2x first to get 2x cubed minus 16x squared plus 14x plus 6x squared. Now I'm distributing the 6 minus 48x plus 42. And I don't want to leave it like that. I'm going to combine like terms. So I get 2x cubed and then negative 16x squared and a positive 6x squared will give me a negative 10x squared. Then I have a positive 14 and a negative 48, which gives me negative 34x, and then plus 42. So this is my answer in standard form. And actually, with standard form, I have another point I can plot because I know my y-intercept now is 0, 42. Fix that. So I can also put the point 0, 42 on my graph. Just a straight marker there. Okay, so 0, 42 would be about here. And I can sketch my graph. Okay, so what I'm going to do real quick is, if Desmos agrees, is fast, I'm going to type in both of these equations to check my answer. I'm going to type in the factored form, and I'm going to type in the standard form and make sure that I multiplied correctly, because if I did, my graphs will match. Okay, so I had x plus 3 times, x minus 1 times x minus 7. Okay, and this is a cubic. If I zoom in, or I know it just went away, I'll bring it back. I'm going to type in the standard form that I had, 2x cubed minus 10x squared. Then it was minus 34x, and then plus 42. And if you notice, the graphs are right on top of each other. Okay, one other thing I want to show you is on your notes, if you look at your scales, this graph goes from negative to 5 on the x value and negative 200 to positive 200 on the y value. If you go to this wrench over here in Desmos, you can change the values for the x-axis and y-axis. So again, I'm just going to do that. All right, so my x-axis goes from negative 5, and you can see this on the notes. The y value, or the biggest x, is 9, and then my y-axis goes from negative 200 to positive 200. Okay, so I can just hit that wrench again for it to go away, and this is the sketch of my graph. This is what it should look like. Okay, so I'm going to go back to my notes, and I'm just going to connect my dots. Okay, I think, and there's the sketch of my graph. All right, and that's all there is to it. All right, so I'm going to do a couple more with you. Number 3, this is going to be homework. This is just review. And notice the directions for numbers 4 through 6 said we could find or leave the equation in factored form, which is going to be so much easier for you. Okay, so I'm going to do number 4 for you in the video because they're kind of hard to see. First of all, it's going to give you a coordinate, and in this, besides the zeros, it also gives you this coordinate -1, -0.5, which is right here. It's not marked on the graph, so the points aren't always labeled where they should be. Okay, it's a little hard to see the numbers. This is a -2. Obviously, this is on the origin, so this is a 0 of 0, and then we have a 0 of +1. All right, so we're always going to start with the general form. Obviously, we can tell this is a cubic, and since the right tail is down, remember, I know that my a value has to be negative. So I already have a clue that my a value should turn out to be a negative number. Okay, so I always start with just y equals, and I put an a in there, and then I use my zeros to write my factors. And since I have a 0 of 0, that means one of my factors is just going to be simply x. Okay, I don't have to put x plus 0 in parentheses or x minus 0. It's just plain old x. All right, and then I have x plus 2 from the 0 of -2, and then x minus 1. All right, and again, our goal is to solve for a. In order to solve for a, we have to have an x-y pair that works in this equation. Well, if this point has to be on the graph, then this is one of the infinite number of points that has to work in the equation. So I'm going to substitute a negative half, or negative 0.5 for y. Okay, a I'm solving for. And for all the x's, I'm going to substitute negative 1. So negative 1 is my x, negative 1 plus 2, and then negative 1 minus 1. Okay, and then it's just a bunch of simplification. So negative 0.5 equals, okay, this is going to be turned into a positive 1, and this would be a negative 2. So I have a times negative 1 times a positive 1 times a negative 2. And if I multiply these together, I just get a positive 2. So negative 0.5 equals 2a. And then to solve for a, I'm just going to divide by 2. And 0.5 divided by 2 is just negative 0.25. And I found my a value. So my answer, I'm going to leave this, remember it says I can leave it in factored form, which is super simple. I'm just going to put 0, 2.5, and then I'm going to write my factors with the x's so they work in general with for any coordinate. And this is my equation in standard form. Okay, and if I wanted to, I could confirm the graph and make sure negative 1 and negative 0.5 work on the graph. It really only takes a couple seconds, so I think I am going to do that. So I'm going to get rid of this. So I have negative 0.25 times x plus 2 times x minus 1. And my scale is different, so I could change my scale real quick. And this graph looks like it goes from maybe negative 3 to positive 2, and then only, so I'm just going to leave that as negative 5 to 5 just to make it easier. And then this only goes from like negative 1.5 to positive 1.5. Okay, and if I want to check that point, it's just very touchy. Oops. Oh, I saw it. Negative 1, negative 0.5 was there. Okay, so I just confirmed that my answer was correct. All right, one more for the video. Okay, I'm also going to do number 5 with you because 5 is kind of unique. There's a couple things going on here. All right, so first of all, if we look at the number of turns, there's 3 turns here. So we have just 1, 2, 3. So we know it's 3 turns. Oops. 3 turns. So we add 1, and we know this is a 4th degree. And this one is special because since the turns are on the x axis for both of these, we have 2 double roots. Okay, so this negative 2 is going to count twice. And we also have a double root at positive 2. Oops. So that's going to count twice as well. So that means we have all 4 roots represented. All 4 roots are real. Okay, so we have all 4 roots on the x-axis represented. And it doesn't label this point, but this is our this is our y-intercept, which is another point, 0, negative 2, that is not an x-intercept. And this is the xy that we're going to have to use to solve for a. Okay, so sometimes they don't actually put the coordinate. They just show you another point that is not part of this. You know, we can only take the roots from here. So the factors only come from the x-axis. Any other point can help us in finding the a value. Okay, so when we're writing our factors, we have to make sure that those double roots are accounted for. So we have our y equals a. Okay, this is how we always start. And then we have an x-intercept of -2 gives us a root of x plus 2, and that's squared. And then we have the +2, which will give us a factor of x -2, and that's squared because they're both double roots. So all 4 roots are accounted for, which takes care of our 4th degree. Okay, so now we're ready to solve for a, and we plug in our y, our -2 for y, and we plug in a 0 for our x's. So 0 plus 2 squared, 0 minus 2 squared, and we follow order of operations. So 0 plus 2 is just 2. Okay, so I'm just going to write this out again. We have 2 squared. Actually, I'll write it like this first. And then over here, we're going to have -2 squared. Okay, 2 squared is 4. -2 squared is also 4. And then we have to multiply 4 times 4, so we get -2 equals 16a, and then divide by 16. And in this case, our a reduces to -1/8. It's okay to get fractions. Actually, it's very common to get fractions for the a values for these. And our a value is negative, which reinforces that our right tail is down, so we know we should have received or ended up with a negative lead coefficient. And again, since the tails are in the same direction, that reinforces our even degree. So for this one, our factored form is y equals -1/8, and then we have x plus 2 squared and x minus 2 squared. And since it only takes, like I said, a second to graph it, I'm just going to do this on Desmos. Okay, so I have 1/8 for that. X plus 2 is already there. Let's square that. Change this to an x minus 2, and I'm going to square that. And I can just do this. And I can see perfect. I have that y-intercept, right? I have my double roots. It's exactly the same. I know I'm correct. It took literally seconds to correct it. All right, so you are going to do number 6 on your own. Okay, remember to think about the degree and take account the double roots there. And for this one, just to clarify, 136 would be a point right about here. This is the point you're going to use, but they should really put the dot there. Okay, so your homework is taking the notes and then finishing questions 1, 3, and 6. Make sure you show work for everything. Have fun, and you know where to find me for help. And I'm try to sign off. Oopsie.